Welcome to Instruments Direct. Our training program today is on the Fuji Portaflow-C model FSC-2. In our program today, we are going to talk about measuring flow with the Fuji Portaflow, basic programming, transducer sensor installation, measuring temperature for those BTU applications, and logging and retrieving data. For those who are not familiar with the ultrasonic flow meter transit time theory, it's a unique technology that you basically take a sensor and clamp it or handhold it on the outside of the pipe, and it will monitor the liquid flow inside the pipe. In the theory of operation, here's a good analogy. We have a man who's going to cross the river in a rowboat, and the flow is going from left to right here. And so when the man gets in at the river, he crosses the river in the rowboat and goes downstream, and it takes him a certain period of time. Now when he comes back across the river, he's going against the current. It takes him a longer period of time to transit across the river. The differential between those two transit times, across and back, is the coefficient we use to calculate how fast the river is going. Again, so when he goes across the river, he goes with the current, takes him a shorter period of time, but when he comes back across the river, it takes him a longer period of time. The differential is what we use. The faster the flow rate, the greater the differential, and that'll mean the faster the river is moving. Here I have a picture, a bird's eye view of a pipe. We got lazy. Instead of the man in the rowboat going across, he's bounces off the back wall and comes to the same side. And the reason why, we're lazy. It's easier to put two sensors on the same side of the pipe. Flow is going from left to right. This sensor is going to transmit a sound burst across the pipe, ricochet off the back wall, and come downstream, and we measure how long it took to get there. This transducer sends a sound burst across the pipe, but it's going against the flow. When it gets back to the first transducer, there's a differential in time. The faster the flow rate, the greater the differential. This is the coefficient we use to calculate the volumetric flow. Now there are other configurations with the installation of the transducers. The picture in the top by Fuji is referred to as the V configuration, and other manufacturers call this the dual path or the dual crossing, but bottom line is pretty much the same. Traditionally used in applications with smaller pipe sizes, say 1/2 to 24 inches, mostly because it's so easy to do. This configuration is the man in the rowboat equation we looked at, where there's one sensor on each side here. This is commonly referred to as the Z configuration of the single path. And this is used traditionally in larger pipe sizes where you need more power. Say 24 inches or larger is the standard, but you can use it on smaller pipe sizes if you have poor pipe wall conditions and high level of solids. So Z conditions used for larger like applications. Ultrasonic transit time flow meters need straight run of pipe for optimum flow performance. Every meter has a certain set of parameters, and I think you'll find the straight run of pipe parameters pretty much industry standard. So what you want is what's called a symmetrical flow profile. I need my elbow here. I need 10 pipe diameters to here and another 5 pipe diameters here before the next elbow. So that's what we call a symmetrical flow profile. If we were to cut away the pipe wall and look inside the pipe, these elliptical shapes represent the flow either through laminar or turbulent or fast or low flow rate. And what is important about them is the flow rate is the fastest at the center in both of these here. Analogy, a man in the motorboat going down a river with the weight cast out to the side. In this case there, the liquid's going through the pipe, and then either gravity or friction is grabbing a hold of the processed liquid and making it going a little bit slower here than it is here. The symmetrical flow profile is basically when you draw a center line down this, the top half of flow equals the bottom half of flow. And this situation will occur if I have an elbow, 10 pipe diameters, put my sensor here, another 5 pipe diameters and elbow here at flow rates of around 10 feet per second. Higher flow rates, more straight run of pipe. Lower flow rates, less straight run of pipe. Bigger obstructions at an elbow, more straight run of pipe. Picture to the right is referred to as an asymmetrical flow profile. In this case there, I have my flow going up this 90-degree elbow. Shorter distance, longer distance, guess what? I get a tumbling effect after this elbow here. If I put my transit time flow meter right here, I'd probably get a fault condition, probably wouldn't get anything at all. But if I went down 10 pipe diameters and put my sensor here, I'd probably have a successful application. So give us your traditional 10 to 15 pipe diameters, and you should be set for most applications. Now, you can get a reading under acute situations, but you're not going to get your overall accuracy statements there. The Fuji transit-time flow meter is destined and its objective to be a 1% type of technology. That's based upon the math, and the math basically dictates that this transducer will be located here and this transducer will be located here, and the time it will take to get from this transducer is predetermined mathematically. That's all known in advance. So if the pipe was just full of liquid with no moving flow, these two sensors would be saying hello, back and forth there, everything's perfect. But what if I had a short run of installation? Say I had an elbow over here. If I had an elbow over here, then my flow profile may actually be distorted. And it will also distort my signal. So the signal will actually be carried upstream or downstream depending on the application. And the only way I'll be able to see it is to move my transducer away from the calculated position. So if I move it away from the calculated position, this is called prospecting. The only time you do this is when you can't get a reading at all. I mean, there's something funky inside the pipe. There's a rock or pebble, or it's not smooth on the inside. You're going to get carried upstream or downstream. And in that case there, you might be able to pick up a reading, but it won't be nearly as accurate as it is at the calculated reading. Now, to make this even more complicated, what if I had a short run of pipe and I had multiple flow ranges? So in the morning I measured 5 feet per second and I could actually get a reading. In the afternoon I measured 16 feet per second. Well, look at that. I moved my flow profile. I had to actually move the sensor in the same pipe as the flow rate changes to pick up the flow. Then what about in the morning? In the morning I had flow rates of only 3 feet per second. So the flow profile changed again. So for spot checking, that would be an absolute nightmare. For dedicated installation, you would actually lose your signal. So you need your straight run of pipe for optimum performance, especially for a dedicated installation. And if you do it on a portable application, you may be moving your transducer around, but you're not going to get the accuracies you're trying to achieve there. And this is what I usually get when I hop in the car, drive 200 miles to do a flow survey for somebody without pre-qualifying the application. This is a bad application. And the only thing you can do is go upstream or downstream. You can't make the flow meter work on something like this, so you don't try. So an upstream, downstream may actually require somebody getting a backhoe out and digging up a pipe. So if that much labor is required before you do a flow study, you need to do that in advance and have somebody do the work before you get to the job site to save yourself a lot of time. Even a good installation requires some effort. You may need scaffolding or a ladder to get to the pipe with the required straight run of a pipe run. It may be insulated or have access difficulties to get to it. So in this case there, even a good application takes a little work to get to the right installation point. And then there are the trick applications. Go to a big box store and look up and you would just see gorgeous plumbing across the ceiling there and just perfectly laid out, picture perfect there, and they'll have some of these bright colored connectors on them, and the connectors work absolutely fabulous, but they do have a surprise. The way that they're attached to these thin wall carbon steel pipes here is they tend to ferrule the ends of the pipe. For bad description, looks more like an ice cream cone, and guess what? That really disrupts the flow profile 10 pipe diameters down here. So even you have this perfect application there, you need to go down double straight run of pipe to get away from the disruption from these type of connectors there. You can go on the roof with a cooling tower application. You can go in the basement to look at your boiler room. You can go look at a data center. You can go look at any industrial wastewater application. Basically what you're monitoring is pump performance, and you may require some effort to get to those flows. You may have to remove insulation. You may require scaffolding there. But again, it's all about the pump performances, and that's the value of using this portable technology. Even on a wastewater application where you have gravity-fed applications, you got to have a full pipe for a clamp-on ultrasonic transit time flow meter to work. And if you don't have a full pipe, guess what? You're not going to take care of business. House rules that I use there on a gravity-filled pipe, if you've got in excess of 1 foot per second, usually the pipe is full. If you got flow rates less than 1 foot per second, red flag comes up. You might need to quantify the application. Flow rates less than 1/2 foot per second, it's high probability that you don't have a full pipe application there. So keep that in mind when you look at a water and wastewater application. So where does an ultrasonic transit time flow meter work? Well, they work in any aqueous slash liquid application that's got a rigid metal or plastic pipe. Half inches and up, you've got the technology there. Transit time flow meters tend to work on ultra pure liquids, dirty liquids, but they don't work on sludge applications. And generically speaking, you can put this meter on deionized water, refined jet fuel. It's got a specific gravity of 0.4, so it can do in the ultra clean. No solids required. You can look at water, you can look at sewage, but you can't look at sludge. So ultra pure up to about 2 to 3% suspended solids. And again, sludge. What's sludge? Sludge is ever have oatmeal for breakfast? That's sludge. Sludge is traditionally high solid bearing applications that you use, say, in the pulp and paper industry, the mining industry, the dredging industry, and so on. Those are the kind of applications that are not that common. So those would be served better by an ultrasonic Doppler flow meter. In this case there, the ultrasonic transit time flow meter, if it's a liquid application, 98% chance it's a transit time type technology application. So I said water, energy management, HVAC, chemical process, wastewater, food, irrigation, and the list just goes on and on and on. Closed pipe full of liquid, petrochemical industry, doesn't make any difference. You've got the product. So the new Fuji Portaflow-C series model FSC-2, if you were to look at this meter versus the Dash 1, you wouldn't notice any difference except someplace on the back panel you'll find a 2 versus a 1 on the device itself there. What's the difference? The difference basically is they updated the GUI interface to accept the new array of transducers, and they updated the signal processing to support the new transducers there. So same old, same accuracy. And if you talk to my calibration manager, he will tell you that the Fuji out of the box is superior accuracies to any of the other brands that we have. So tell us some more. Of course I will. The portable ultrasonic transit time flow meter is designed for ease of use. It has evolved away from the big old suitcases of day of yore that you had to carry around your 20, 30-pound big box to monitor your liquid applications. It's about the size of a big voltmeter. It's designed for ease of use and discovery process. So if you need to decide a new chiller plant, you need to know what your flow rates, current flow rates are before you make an investment in that facility. So a discovery process with a portable device, either spot checking or leaving it there for a period of time, will allow you to compile all the data you need based upon your current statistics. It's also ideal for spot check flows. For example, you have a municipal facility full of mag meters, turbine meters, and so on. You need to do annual calibration. You're going to pull your mag meters out of line? I don't think so. You're going to use a portable device you're going to strap on nearby, and so flow survey people do that, or the maintenance people can do that themselves. So you can do water studies, you can do energy studies. Temperature, BTU calculation studies are hot potatoes right now. So you can monitor flow along with temperature. You can even do pressure, and you can compile all that data within your data logger on the flow meter itself there. And the biggest thing that's happened in the transit time market with the Fuji is been designed to be used by everybody and anybody. In 15 minutes, we can get you up and running with a Fuji Portaflow-C ultrasonic transit time flow meter. We offer the training video. We have 2-page manuals, and we have a whole team of support people there to get you up and running in no time whatsoever. So the other side, of course, is always comes down to the budget. Well, a handheld flow meter is about $5,000. Then you need to have one or more transducers. They're about $1,100. So if you were to make a basic system with flow meter with one transducer and the electronics, you're about $6,100. So the question is, what do you want to do with that? Are you going to use it more than 3 months of the year? Then you should buy it as a capital expense. Or you need something to monitor pump performance today? Why don't you rent it? You can rent it for $600. You can rent a $6,000 device for $600. So now we have the most accurate flow meter in the market, the easiest to use flow meter in the market, and I can either buy it or I can rent it, so there's no excuse. If you have the metering application, the technology is available and ready for you to use. So I said it's about the size of a big voltmeter, and on the top here it usually has a carrying strap right here, and all the ports are on the side. These are LEMO connections. This is a big display that I can read, color display that I can read without my glasses on. 12-hour battery, and in the bottom of this device is where we keep the SD memory card to save all that data for your data log, and wait until we get into that. That's really sweet. And if you prefer, you can use a USB cable to take the data out, but in all honesty, I've never used it because there's no reason to. Here's the changeroos. Here's the transducers. Fuji's largest fault is they change their transducer part numbers like I changed my shirt, and the GUI interface is not always up to date, so people make their inquiries all the time. They usually use the same prefaces, the last two digits there. But what they've done now is they have compiled the 31 and the 41 sensors there into the FSC, which will work. It's a 1 megahertz transducer with a different crystal angle, which has enhanced its performance even more. It's ideal for 2 to 48 inches, and in some cases we've gone up to 60 inches with this device in the Z configuration. The standard transducer, the FSD-22 2 megahertz, has been around forever. It still works in a half to 4 inches. Its new part number is FSSD. So these are the two workhorses for the Fuji Portaflow-C. It does have, little known, but a half megahertz sensors, which are both about the size of a brick, that you would use more so for like your penstock applications, your 100-inch pipe applications. So they're not designed, I wouldn't recommend to use them for your 8-inch applications. Definitely use this device there. As I said, this, though it's rated for 48, I'm sure you can probably get up to 60. So when you get above that, then consider this application there. And they also have an extremely expensive high temperature sensor there, which works for pipe sizes 2 to 16 inches. We do have some other choices if you get into that kind of problem. Pictures of the transducer, here we go. The FSSD, half to 4 inches, looks just like it did before. BNC to LEMO cables. Now the new FSSC looks like the other old transducer, actually looks like a lot like the old FLD11. BNC connectors, so BNC to LEMO, they're not potted like they were with the FSG31. But look at this blue bar. Pray tell, what could that mean? We'll see that in a picture next. And here's the big blocks for the half megahertz transducer. Here's your transducer. Still fits in your suitcase there with no additional modifications. But look at this. This blue bar is also a slide that you can take it and slide it to the left and slide it to the right, so you can do a V configuration up to 24 inches without disassembling the transducers. So it slides into, it transforms is a better word, into a larger transducer, rail-wise. And if you'd like to do a Z configuration, guess what? They pop off and you have two separate rails, each containing a transducer or sensor head. So this is way cool for your small applications and your large applications. So it's adaptable to go from 2 inches to 40 inches and probably a little larger than that. Again, BNC to LEMO connections there. Those have questions have asked, what can I use the new FSS transducers on my older FSCS-1 meter? And the answer is yes. You can upgrade your firmware with the new GUI interface, but it's interesting. You can basically go to a website, update your SD card, and upload it. But if you send your meter in to us for your annual calibrations, we'll update it for you for free. So just let us know how we can help you out there. The device has a GUI interface screen. The measurement screen is the pop-up when you turn the meter on. And basically you have the ability to customize it. The top line, we traditionally make it read flow rate, velocity, and totalization, but there are other parameters. You can move it around to your preferences there. You can program anything that you want from the face right here. And then the bottom notation there, after you're up and running there, this says that everything's ready to go for your application, so you have everything's in a normal situation. So to set up for an application, step one, we go to the site setup. And so to get there, we basically press the menu key, then select site setup, and then we go to process setting menu. Once we're inside, you'll see a number of pages, and they'll go from page 1 to 4. And in the process setting menu, we will set the 3 basic pipe parameters. So the one on the top there, although this is set in metric, of course we can program it in English. You have a drop-down menu. You can do pipe OD and so on. And this is the area that most people make the biggest mistake. They make the biggest mistake because they put bad data in. Every meter goes out the door with an ANSI pipe chart book. You can also download it from our website, and it's included in the big manual as well. If you have a certain pipe size, you have to put the correct pipe size in. This is not a piece of lumber. This is not a 2x4, and by the way, a 2x4 is no longer a 2x4. Such as someone would have a 3-inch pipe, for example, and they'd put 3-inch in a carbon steel pipe. A ANSI pipe chart book for a carbon steel 3-inch pipe is 3.5 OD. Wrong data in, bad data out. Put the right pipe size in, you get good data. Then there's a drop-down menu after that to select your pipe material. It's got a gazillion different flavors of pipe material. You have something exotic, then go to other, and we have other charts to give you some exotic information. Pipe wall thickness, again, most of the time, 95% of the time, you're going to have Schedule 40 piping. Most of the time, if you're going to use copper, it's type L piping. If you're going to use ductile iron pipe, it's class 52. These are the high majority of applications that you can put in there. Again, use your ANSI pipe wall chart for that data. We do have ultrasonic thickness gauges. Again, they're optional and usually don't serve a purpose because the thickness gauges will monitor the paint thickness, and they may measure if you have any metallic buildup inside the pipe, like rust. They will not measure any soft gooey stuff or if they have any calcium type of buildup on the inside of the pipe. So for the most part, the ANSI pipe chart book is usually more than sufficient for most flow survey applications. So we put that data in. If you have a liner, you need to put in the liner information like your mortar lining and so on. Then we need to select the flavor of your liquid. Most of the time, again, you will be putting in water. The reason being, the technology is evolved again from the days of where you had your old controlotron meter 10, 20 years ago. Mathematically, it worked fabulous, but you couldn't deter from that. You had to put the different sound speeds in for everything. Not so anymore. Now it has an auto gain function that basically the meter will allow you to digress plus or minus 10% of the sound speed without any substantial effect to the performance of the meter. And you will actually, if you looked at the diagnostic screen, you'll note if you even put in water, it'll change the sound speed to optimize its performance there. So for those of you who have your traditional HVAC applications with your 30% glycol and your 70% water, well, if you looked at the sound speeds of water and the sound speed of glycol and you divided them up and added them up, you'll note that it's still less than 10%. So in that case there, 30% glycol and water, you can just leave the setting on water. So again, you can do the culminations of different processed liquids. You have petrochemical application, you'll find a drop-down menu for that and so on. So pick the right processed liquid. You have an exotic proprietary liquid. A good way to shoot for that is to use the specific gravity as a point of reference and prospect, or you can contact us, and we have people here that actually have those really thick pocket protectors there and slide rulers and like to do bulk modulus equations. So again, we can help you out with something exotic. Moving farther down, you notice the viscosity and other parameters, they will be predetermined by the drop-down menu. So house rule, we don't adjust the viscosity sensor setting. Sensor mount, in this case, we've selected the V configuration. And then after that, we go and hit the decision. Now, one screen pops up that still gives me a hissy fit. It says, after sensor installation, please adjust 0 point. And if you learned anything from us, don't touch the 0. No. Don't touch the 0. The 0 on the meter is just fine. If you have adjusted the 0, give us a call. We'll show you how to reset it. It's not a big deal. But you cannot get a 0 reference. And I don't know why these guys say this. People that are in a flow laboratory, little white coats. In the field, it's hard to get 0 reference unless you went to, say, a sprinkler system or had a standpipe. If you have a flow loop and you close off one valve to your left and you close off one valve to your right, you still get what we call the jello effect, going back and forth, back and forth. This Fuji meter is so sensitive, we actually program it when we ship it out the door to not see anything less than 1/10 of a foot per second. We program as a cutoff point. You can change it if you need to, but that's our low flow cutoff because there's just too much data in there, and it just affects the performances. So if you're getting a reading that's always 10% high or always 20% high, you probably set the 0. So talk to us. We'll show you how to reset that. general rule, the only time you ever set the 0 point if you're working with things that are in the tenths of a foot per second. So you're not for the most part. So leave it alone. So when that pops up there, it will give you the sensor spacing. In this case there, it's metric, but if it was English, it would give you so many inches apart between the transducer and the method of installation. So then we need to put the sensor on the pipe. So as we said before, we needed the traditional 10 to 15 pipe diameters, longer if you have a major obstruction. And we need to get the pipe ready to put the transducer on. So if we had installation, remove that from the pipe. Do not cut out the little windows or the little puzzles and put the sensors in there, because that never works. If you have installation, horizontal cut, 2 complete circumferences, peel it all back like a bed sheet off the bed, then put your sensor on the pipe. Then you can put the installation on top of that. The transducers do need an acoustic couplant. Before you put that on, you've got to wipe the surface clean. Don't bring your grinders anymore. It's old news. Just a rag and maybe wire brush. So anything that's loose, knock it off the pipe. Don't worry about the paint. Put an acoustic couplant. Why do we need an acoustic couplant? Well, let's see. The cousin of the guy who was in the motorboat going down the river, he's out in the distance there, and his brother that's in the rowboat hops out of the rowboat and is swimming around in the water, and he can see his cousin down there in the motorboat. But then he goes underwater, and all of a sudden it sounds like the motorboat's right on top of him. And the reason being, sound is transmitted faster through the water than it is through the air. So sound is transmitted faster through the acoustic couplant or the grease than it is through the air. Sensor's flat, pipe is round. We have multiple different flavors of grease. My favorite is a silicone grease because it's just viscous, doesn't care about moisture, it doesn't care too much about most temperatures there, and it does a better job. Some brands have water-soluble grease, which are great. You get wet on the pipe, you get some heat on the pipe, they don't stay on the pipe. The only drawback with the silicone grease, if you have a pretty pipe, you'll never paint that spot again, no matter how much you clean it. You take your flow meter on an airplane and you carry it on, and the TSA takes away your tube of grease. What do? When you get to your destination, you stop at Walgreens and you get a tube of Vaseline or KY jelly to get you by. But again, for long-term use, silicone grease is my preference. It's one of the many spare part items we do offer on the website. So we butter up our transducer just like toothpaste on a toothbrush. Put it on the pipe, adjust your spacing. You can hand hold it or you can strap it to the pipe. Locations on the pipe. Top of the pipe can have air. The bottom of the pipe can have solid. So anything on the side, anything at 9 or 3 o'clock is usually the best installation point. Now the logging, this is in the way cool, as my daughter says, I can't say that anymore, I'm too old for that. In the way cool category, if you're up on the ladder and you say, gee, I sure wish I brought a pencil and a notepad to jot down what I see on the display there, all you need to do is press the log button and it will take a screenshot and save it. So we're now talking, laptop functionality here with this device. And that data is saved in your SD card. Now if you want to set this up for a short-term or a long-term log, now we need to go in and program the meter with the start and stop time and what you'd like to log. So in this case there, we go back into the menu, and now we go to the data logger tab, and under the data logger tab, then we select number 2, logging. Once we get inside there, now this we use traditionally a 2 gig or larger SD card, which basically means you can store millions of records. Millions. You can store data from now, once a minute, to 6 or 9 months out. Okay, so you don't have a storage problem. For example, like the PT878 only has 100,000 data points. You can store data until the cows come home, and means you're not going to download it every day. So make a point to use an alphanumeric system so you can identify your file later on. And we'll show you later. It's going to have like a C drive file with a bunch of different files. You'll need to be able to pick it out later on. So once you go in there, you also then begin to select the type of data. As I said, we don't care how much data you have. Before you just had to limit that because every data point counted as an incremental data point. So in this case there, most people tend to monitor flow rate and total, but you can monitor other things. You could even monitor temperature, or excuse me, that's the next one. You can monitor pressure input, and then we'll look at temperature under the BTU mode later on. But that's all the ability that you have. Then after we go into there, we go and set up the timing. Now, with this type of logger, this is a Japanese meter, so it's a Japanese calendar. So it's year, month, date. is the start time and the stop time as well. So if you're going to start this thing, give yourself enough time, because if you missed your start time, you got to wait a whole year for this thing to wrap around and actually start. And you can actually do a desk practice log there. It's very simple to do to get your confidence up there. And the bottom here is the interval. You can go, it's adjustable from 10 seconds and on up. The only caution I have is, depending upon your application, if you're looking for toilet flushes, then you go down to the 10-second intervals. If you're looking for traditional process control monitoring, in that case there, most people tend to sample once a minute. With that in mind, you get 1,440 data points in a day. So that's flow rate, and then times what other item you've checked off as well. So that's a massive amount of data. You're going to use Excel to read the data, so if you have a gazillion data points there, Excel will gack at a certain point in time. You have too much data, you may have to chop up the files there. So keep that in mind. So we start the logger, and away she goes. She's logging data. Then later on, we wanted to check what's going on there. We would go look at the logger data, and in this case there, these are all the files in here. So this is, for example, is the quick file, but filed by the date and time there. That was the one button you pressed up on the ladder, and down over here was another file that you had. So you can keep all kinds of data there, so make sure that you identify it so you can download at a later point in time. And the way to get the data out is to remove the SD card. So as I said, it also has a USB cable and software. Why bother? So here's the process. You take the SD card out of the flow meter. Boom. You stick it in your PLC, your laptop, your computer, and if you don't have an SD port, we give you an SD to USB adapter, and if you lose it at Office Depot, it would probably cost you $7 to get a new one. You plug it in. You now turn on your computer, turn on Excel, and open the CSV file. No software required. Life is very simple. Don't worry about Windows today. It's basically a jump drive. That's all it is. So then you can look at your data. It's in Excel. You can do anything you want. If you want to do some fancy Excel equations or fancy Excel charting, we do that very well here. Just contact support and we'll point you in the right direction. Temperature is a hot potato. If you lived in Europe, you may get the bill for your apartment or flat in BTU. They've culminated everything together, and when everything's all together, people tend to spend less money. And so everybody that's in the university business or large facility business or large office complex business wants to know their energy consumption. And the way they do that with the Fuji meter is we'll take the portable meter and we'll clamp a sensor on the supply line. Now the supply and the return line are in a closed loop. So the flow is the same in the facility itself there. So we only need to monitor once. We're monitoring flow on the supply. And then we're going to monitor temperature on the supply. And we're going to clamp the sensor on the outside of the pipe. Then we're also going to monitor temperature on the return line. And what the equation is we need to know flow and differential of temperature to calculate your BTU. And guess what? All this data goes back to the Portaflow-C logger. So it's going to log flow, temperature 1, temperature 2, and calculate the BTU. So when you download everything, you have all the data that you ever possibly wanted to get. And so the kit, that's optional kit that you can add to it. You can buy it, you can rent it. Basically has a power supply and a line cord and 2 strap-on platinum RTD sensors. And the way again it works basically is you take the sensor, we give you a tube of some thermal compounds like zinc oxide, real gooey sticky stuff, and it transfers the temperature from the metal pipe wall to the sensor. We strap this on the pipe there. So you can do this as a short-term test. Most BTU flow studies last a week or a month and so on. You have the ability to do that, hence why the line cord's not a big deal. No one's going to do BTU studies for 10 minutes. You're not going to have enough information there. So this is different than a wetted sensor. The key here is we're looking for our equation, the temperature differential. So if you were to put this sensor on the supply line at 3 o'clock and then put another one on the return line at 3 o'clock, you're going to have the data that you need. And this is important too. These transducers that come from us, the temperature sensors, are calibrated for plug and play, and they're better than 1% temperature differential. The problem is if you use hokey temperature monitoring, if you have bad temperature differential monitoring, you've just screwed up the whole BTU calculation. You're off a couple degrees, you can be off 10% or more on your BTU calculation, and so the whole thing's done in vain. So very precision use of our package that we have there. And the way that you set this up, so this is in the advanced level if you're monitoring BTU. We need to go and set up the energy functions on the Portaflow-C. This option can be found by standing in the Site Setup menu or starting in the Site Setup menu, and then select Unit of Output. And the bottom two options provide you with the unit and total settings. So before you go to the System Setup menu, we need to take a look at the analog input and output. So locate the analog input and output and toggle it from not used to use, and this will engage your Portaflow temperature input. Once the analog input output has been initialized, now we advance to input channel 1 to set a supply. So as I said before, this collects all the data, so when your end user looks at this, the chart will say temperature 1 is the supply line and temperature 2 is return line. If you've got bad BTU calculations, the first thing to do is go back and analyze all the sub data. So you have flow and the temperatures, and it'll be nicely identified here. And the same thing with input channel 2, set that up for your return. Then you go to the System Setup menu and then to the Energy mode. You locate Mode option and toggle it from not used to use, and this will gauge your Portaflow temperature function. And so as I said, the hardware is calibrated. You put it on a pipe as I just mentioned there, and you're done. And the logger is all set to go to accept the data. Should you have to use somebody else's temperature sensors, you do have the ability to calibrate for it. You won't get the degree of accuracies if you use somebody else's temperature sensors than our kit. If you have to use wetted RTDs, again, you have the ability. It's the 3-wire platinum input that we use, and then basically we just need a 420 milliamp input signal with a device should you need to do something like this. Features, we do have a custom profiling probe, so if you wanted to look at the shape of the parabola there, you would get this sensor, and it is a custom Portaflow-C that operates this. The standard Portaflow-C does not use this, so it might be better you to rent this as opposed to buy it if you have an exotic application. So that's basically what's new with the Portaflow-C, the FSC-2. And so what about us? Well, we are an ultrasonic flow metering company based out of the Atlanta area. We are global, and what we basically do is we offer ultrasonic flow meters, the Fuji of course, and many other different brands for sale and for rental. We've been at this for over 37 years, so we know a little bit about the technology. We have our own flow laboratory, our own engineering group, and our own support group, as you'll find out. It's a picture of Paul in the center standing in front of our R&D loops, and you'll see a picture of Lane, one of our sales engineers, on the right hand side there as well. Should you have any questions about the cables, the grease, or like to see other training videos, you can go to the Learn tab across our website at instrumentsdirect.com. You can look at any of the videos, this one included, free of charge. We do host a new one about every month there. If you want to look at operation manuals, software, cables, and spare parts, you'll also find this on our website. So we appreciate your attending our program today. Thank you very much for participating. If you have any questions, give us a call on our support line or drop us an email. Thanks for coming.